Over the page, we've got some skeletal muscle, and you can see the stripes. That's why it's called striated skeletal muscle. And name the two myofilaments. Those are the two main proteins, which are the thin and then the thick bands of proteins. So the thin is actin, and the thick one is myosin. It just says name them, so that's all we need. Explain the function of a sarcoplasmic reticulum. So those are sort of membranes. So sarcoplasmic reticulum are those sort of membranes around the outside. And their main function is to release calcium ions, which will have an effect on the contraction. So they release calcium ions, and that helps with the contraction. So this helps with the muscle contraction. So that's the sort of easier 2 marks there, and then you need to sort of name the bit that the calcium ions actually help with, and one of those is controlling ATPase activity. Calcium controls ATPase activity, and we don't really need to give much more than that. Oh, hard a third amount there. Question 4. We're on more familiar ground now, really, with the action potential, and you should know a lot about the action potential now. And we want point 1 on the graph, so we're just going to talk about this point 1. What happens to make this graph go up like that? That's all we need to do. And this is, does it tell us which stage we're talking about? Oh, there we are, action potential. So we're talking really about action potential here. And so what happens is sodium channels open. So sodium channels open, and this is at minus 70 millivolts. Then what happens, because these channels are open, sodium can move in to the axon. So remember, we've got our axon there. We've been pumping loads of sodiums out, and we've been pumping lots of potassiums in. So we've got gradients for sodium and potassium there. And so the first thing that happens is we're opening our sodium channels so sodium can go in. So sodium can now enter the axon as now permeable to sodium. So channels open, the axon is permeable to sodium now, so sodium now will go in down its gradient. So sodium goes in to the axon down its gradient. And how does this happen? By diffusion. So pretty simple answer, but you've got to say all the technical words, and that'll make it go up to, plus 30 and plus 30 millivolts at the end. And then how hyperpolarization happens. So hyperpolarization, we're talking about this area down here, hyperpolarization. So why doesn't it just come down to minus 70 again? Why does it actually go down further? So slightly more difficult this. You should have got the previous 4 marks certainly. But hyperpolarization, you need a little bit more detail. And it's to do with those potassium channels. And what happens is they've opened to allow this to go down, but they're not shutting as quick as the sodium have, and so you get an overshoot there. So these close more slowly than the sodium channels. You've got, I'll come back to that one, but the potential difference, more than minus 70 millivolts, goes to minus 90 on that one. And you've got some potassium ions diffusing out of the neuron. Which makes it even more negative because these are positive ions that are going out, so it'll make it more negative. So slightly harder to explain hyperpolarization.